in today's lecture, we will focus on some simple points. So next point is sum, product, and quotient of sequences. That is how to add two or more sequences, how to subtract sequences, how to divide and multiply by sequences. So this is a very simple point. Okay. So first point is sum of sequences. Suppose we have given two sequences. One is S defined by n term Sn, and another sequence T whose n term is Tn. Then their sum is nothing but add to sequence term by term. That is, add first term, then add second term, up to so on. See, general notice is sum of n term, so that n belongs to natural numbers. So just add each term. So first term of S, second term of S. So this becomes first term of S plus T, like this. Okay. So suppose we have given a sequence S defined as 1, 3, 5 up to so on. Sequence of odd numbers. Okay. Then we also given sequence T whose elements are 1, 1 by 2, 1 by 3 up to so on. This is the sequence of sequence 1 by n. Okay. Now new sequence, then the sum of two sequences plus T, nothing but adding the term compound wise. Okay. So first element here 1, here 1. So first element of the sequence S plus T becomes 1 plus 1, that is 2. Now similarly second term of the sequence becomes 3 plus 1 by 2. 3 plus 1 by 2. Then add third term of S and third term of T, becomes 5 plus 1 by 3. Up to so on. Here n term is twice n minus 1. Here n term is plus 1 by n. Okay. And then up to so on. Okay. Now, so S plus T becomes first term is 2, second term is 3 into 2, 6 plus 1, so 7 by 2. Third term becomes 16 by 3. Similarly, now add these two terms, n term of S and n term of T. Okay, this becomes n into twice n minus 1 plus 1 upon n up to so. This is the S plus T. Okay. Now understand? So similarly, S minus T, subtraction of two sequence. Similarly, just subtract each component. So first element of S minus first element of T become first element of S minus T. Okay. So it is defined as Sn minus Tn such that n belongs to natural number. Okay. So take again this sequence S, this sequence T. So S minus T becomes, just subtract first term of S with just subtract first term of T by first term of S. So first term is 1 minus 1, so become 0. Second term in S is 3, and in T it is 1 by 2. It is S2, this T2. So S2 minus T2, here S3 minus T3 up to S minus Tn and up to so on. Just put n is equal to 1 to up to so on. So we will get second term as 3 minus 1 by 2. Third term is 5 minus 1 by 3 up to n term. Here twice n minus 1. Okay. So here twice n minus 1 and minus n term of T, which is 1 by n. Okay. Up to so on. Now this becomes, so first term 0, second term is 5 by 2, third term is 14 by 3, then n term becomes n into twice n minus 1 minus 1 upon n up to so. So this becomes S minus T. Just subtract compound wise. Okay. Now third notation is scalar multiplication. This is the third term, scalar multiplication. Just what is this mean of scalar multiplication? Nothing but multiplying some given sequence by some scalar or by some constant element or number. So suppose S is our given original sequence. Then what is C into S or CS? Okay. This C is nothing but here some constant or scalar number. Okay. So just multiply each term by that constant C. We will get our C into S. This new sequence becomes just multiply each term by the scalar C. Suppose S is again this sequence 1, 3, 5 up to so on, and take C is equal to here 5. Okay. Then 5 become. Just multiply each term of the S by 5. So here first element is 1. So we have to multiply each element by 5. So this become first term becomes 5. Next 5 into S, 5 into 3 second term 15. Then 5 into 5 25 up to n term is twice n minus 1 of S. But you have to find 5 into S. So 5 into n term. So the n term of this sequence 5S become 5 into twice n minus 1 up to so on. So this is the scalar multiplication of sequence. So next term is product of sequences. It is also very simple. Suppose we are given again two sequences S and T. Then the product sequence, that is S into T, is defined as product of n term. Okay. So product of first term become product of first term of S and first term of T become first term of S into T. Just multiply component wise. So first term here, take multiplication, become first term of S into T. Similarly, other term. And in the similar pattern, the division of sequence or quotient of sequence S by T, nothing but again component wise division of elements. Okay. Suppose we are given sequence S, sequence of odd natural numbers, and T, sequence of even numbers. Okay. So S into T, we have to define or form a new sequence S into T. So how to list the element of the sequence? Just multiply component wise. That is first element of the sequence, nothing but the product of first element of S and first element of T, which is 2 into 1, which is 2. Second term, take multiplication of second terms of both sequence. So 4 into 3, 12. Then 5 into 6, 30. Later on, n term of the sequence is twice n minus 1. N term of the sequence T is twice n. Their multiplication is 2 twice n minus 1 into twice n. This is the n term of this sequence up to so on. We can write one more step by simplifying this word also. Okay. Now, in the similar pattern, we will list the element of the new sequence, that is division of the sequence S by T. But only condition here is that the element of the any element of the sequence T is 0, we cannot write the sequence S by T. Why? Because if 0 comes into the denominator, we cannot write the element is a real number. So here the one extra condition is that Tn must not be equal to 0. Okay. So here no element of the sequence T is 0. So we can write the sequence S by T. So the element of the sequence S by T are formed by division of the elements, first element of the sequence S by T. So what is the first element of S by T? Take division of 1 by 2. That is divide 1 by first element of T. So here this first element of S is 1. So 1 upon first element of sequence T is 2. So 1 by 2. Next, divide 3 by 4. It is the second element. So 3 by 4. Next, 5 by 6. Up to n term. Here n term is twice n minus 1. And here n term is twice n. Up to so this become the new sequence S by T. Okay. So I think you will get the idea of these 5 terms, that is sum of sequence, difference of sequence, scalar multiplication of sequence, product of sequence, and division or quotient of sequence. Okay, so now the very important point, that is limit of sequence. Okay, so we will go to definition later. First we will see one example. Okay, now consider the sequence defined by n term, which is 1 by n, and n is a natural number. Now if we list the element of this sequence, this is nothing but the sequence 1 by 1, that is 1, then put n is equal to 2, 1 by 2, then 1 by 3, then put n is equal to 1, 2, up to so on. Somewhere 1 by n, then 1 upon n plus 1, up to so on. Now we will take a real line. Okay. Now we know this sequence is decreasing. See, first element is 1, then 1 by 2, 1 by 3. Elements are going to decrease. See, 1 by 2 is less than 1, 1 by 3 is less than 1 by 2, up to so on. So 1 is the upper bound or least upper bound of this sequence. Okay. So suppose this is 0, this is 1. So the first element of this sequence is 1. Second is half, then 1 by 3, then 1 by 4. Okay. Then as n increases, we are going towards 0. See, first 1, then half, then 1 by 3, 1 by 4, 1 by 5, 1 by 6, 1 by 1 lakh, 1 by 1 crore, up to so on. We know the sequence has lower bound 0 because there is no negative number in this sequence. So we are, as n, the value of n increases, we are getting closer to 0. So this is the idea of limit. So this sequence has the limit 0. Why? As n tends to infinity, the elements of the sequence are tending to 0. So the definition is a real number L is said to be limit of the real sequence Sn. See, here value of L is 0. Why? If for any small epsilon greater than 0, okay, where epsilon is some positive number, depending, some positive number, and we get value of m depend on this epsilon, such that whenever n greater than this m, okay, whenever n greater than this value m, the difference between the terms of the sequence Sn and limit get very much less than epsilon. Okay, this is nothing but as the value of n increases beyond some particular number m, and then if you take difference between that terms Sn where n is greater than that fixed number m, if you take difference between Sn and L where n is greater than m, if difference goes on decreasing and tends to very small number, then we say that the limit of the sequence Sn is L. See here, after some number, so first difference between limit and first element of 1, the difference become 1 by 2 minus 0, half, then difference become 1 by 3, 1 by 4, up to so on, so that difference get very much less. Okay, so as n tends to infinity, the elements of the sequence are coming very closer to 0. Okay, there is a very small difference between the element of the sequence Sn and L after some fixed numbers, or after some fixed elements. Okay, so this is the definition of the limit of the sequence. The idea is nothing but just we have to find the number such that the element of the sequence going near to the elements after some fixed numbers. Okay, this is the number m such that whenever we take the n greater than m, the Sn, difference between Sn, that is element of the sequence, and that limit is very much less than some very small number epsilon. Okay, so this is the idea of the limit of the sequence. Now in exam, they ask to find the limit of sequence, and you will see some example, and we have to solve that the question of finding limit using this definition. So we will see the example. So your idea of finding limit will become very clear. Okay. So we will start with some basic example. Very easy example. So example is show that limit of the sequence years whose n term is 1 by n is 0. The same sequence we have already seen graphically. Here the sequence is given as s whose n term is 1 by n, and we have to show the limit of this sequence is 0. That is limit n tend to infinity of the sequence n term is 0. Okay. Now we already seen how the elements tends to 0 graphically. Now we have to use this definition. Okay, we have to use the definition to show that limit of this sequence is 0. Now see how we will use the definition. Okay, what is the definition? To prove this sequence has limit L, we have to show that the difference between Sn and that limit is less than epsilon. But when we will find some fixed number m such that whenever there is n greater than m, this difference must be less than epsilon. Okay. Now we are already given that we have to prove here limit is 0. So we know limit is 0. So we will proceed as, so let epsilon is any some small positive number. Okay. The only main thing here is to find the number, fixed number here. If you are able to find this number, then we will get our required answer. Okay. So for finding this number m, we will take this condition. Okay. So we have to find m such that whenever n greater than m, this difference is less than epsilon. Okay. So directly take the difference. Assume it is less than epsilon, and then we get the value of m. If we get value of m, we are done. So suppose, so here we have to find value of m. So suppose difference between Sn and n is less than epsilon. Here Sn is 1 by m. Okay. So we have to find m. So let difference between, so epsilon greater than 0 be any positive number, and here Sn is 1 by m minus limit. This is we have to prove 0. So take limit 0. So suppose this is the less than epsilon. Okay. Now 1 by n minus 0 is 1 by n, and n is natural number, so positive. So mod of positive 1 by n natural, it is a positive natural number 1 by n. So mod of this is again 1 by n. So 1 by n minus 0, 1 by n. Mod of 1 by n is 1 by n. Why? N is positive, so 1 by n also positive. This becomes 1 by n less than epsilon. Okay. That is, now transfer this n right side and epsilon to left side. So this become 1 by epsilon is less than n. That is, n is greater than 1 by epsilon. See, if n is greater than this number, we get this difference less than epsilon. What is the difference? Nothing but Sn minus n less than epsilon. So see, whenever n greater than m, so whenever n greater than 1 by epsilon, this difference becomes less than epsilon. That is difference is less than epsilon. So this implies we must have to take this value as m. Why? Because this fulfills the criteria. See, if n greater than this number, difference is less than epsilon, and we want the same conditions. Why? Whenever n greater than m, whenever n greater than this m, if difference is less than epsilon, if difference becomes less than epsilon, limit of the sequence Sn L, so limit of the sequence 1 by n become 0. So we take, so from this condition we get the idea of value of m. So we choose m is equal to 1 by epsilon. Why? So whenever n is greater than m, which is nothing but 1 by epsilon, we get the difference between Sn and limit which is 0 less than epsilon. So whenever n greater than m, difference between Sn and l which is become less than epsilon. Here we get Sn is 1 by n and limit is 0. So whenever n greater than m, okay, which is nothing but 1 by epsilon, difference between 1 by n minus 0 is less than epsilon. That is difference between sequence and limit less than epsilon. So by definition, limit of sequence Sn is equal to L, where Sn is 1 by n and L is 0. That is limit of sequence 1 by n is 0. This is the proof. Okay. So only thing here is to find the value of n. You have to find number such that whenever n is greater than number, the difference between n term and 0 at the limit must be less than epsilon. Okay. So for that purpose, to directly take last part, that is directly take difference between sequence and limit and consider it is less than epsilon. So using this, we have to find get the value of m. So using this m, we say the sequence has limit and it is here 0. Okay. So next example, which is proving limit of the sequence whose n term is 1 by n square is 0. Now again by observation, we come to know that as value of n increases 1 by n square, the terms are going towards or coming closer to 0. So now we will prove this by using epsilon delta definition of limit. So for that purpose, let epsilon greater than 0 be any arbitrary small positive number. So here we have to find m such that whenever n is greater than m, difference between 1 by n square and 0 becomes less than epsilon. Okay. So let difference between Sn and L is less than epsilon. That is, here Sn is 1 by n square and limit is 0 minus 0. So we assume this difference is less than epsilon. But we have to show limit of this is 0. Okay. Now again, 1 by n square minus 0 is 1 by n square, and 1 by n squares are positive term. So mod of 1 by n square becomes 1 by n square, and it is less than epsilon. Okay. Now this implies transfer epsilon this side and n 1 by n square to this side. So this becomes 1 by epsilon is less than n square. That is, n square is greater than 1 by epsilon. Now we will take positive square root of both sides. So taking positive square root of both sides, we get n. Okay, here taking positive square root, we get n, and this side become square root of 1 by epsilon or 1 by square root of epsilon. So what we get? Whenever n greater than this value, the difference between sequence and this limit 0 is always less than epsilon. So we should choose this value as a m. Why? If we choose m is equal to 1 by square root of epsilon, we get this. Then go in reverse. Then we get this, and later on finally we get difference between sequence and limit less than epsilon. So this is the our required value of m. So we choose m is equal to 1 by square root of epsilon. So then whenever n greater than m, so whenever n greater than m, our difference between sequence and limit 1 by n square and 0 become less than epsilon. So we choose m is equal to 1 by square root of epsilon. So then whenever n greater than m, difference between 1 by n square and 0 become less than epsilon. So by definition of sequence, limit of sequence for epsilon greater than 0, we have find m such that which is 1 by square root of epsilon, such that whenever n is greater than that m, our difference between n element of the sequence and limit required limit less than epsilon. So this here nothing but the limit of the sequence Sn, that is the 0 nothing but the limit of the sequence 1 by n square. This implies limit n tend to infinity 1 by n square is equal to 0. Okay. So only main thing is here to find value of m. If we get value of m satisfying this condition, these elements here become limit of the sequence Sn. Okay.